So here we're asked to just list the multiples of 2 and 3. That is one way of finding our least common multiple. I would like you to list either the first 8 to 10 multiples. So the smallest one is 2, right? So you have 2, 4, right? If I was listing the first 10, I'm going to go all the way up to 20, right? I'm going to go further than that. So, start. So, you're going to have 2, 4, 6, 8, 10, 12, right? Okay? Do the same for the multiples of 3. Multiples of 3. So if I'm reading those, Jordan, I'm going to have what? 15, 18, 21, I could go 24, right? We could keep going, right? If I was looking at this. All right, so if I'm looking at those, the next question says list numbers that are in both lists. So right now I want you to make a list from these two and check with your shoulder partner and see if you agree. I do not want you on this right now, I want you in the notes. Okay? So you can do the notes. I don't care. I do your notes. I don't care. You are numbers. Do you say so check with your shoulder partner, and you can just check with the ladies in front. Okay. Write down as many that you have from both lists. Right. Some of you haven't checked with your shoulder partner yet. Check with your shoulder partner. You guys haven't talked yet. You don't have your list. Would you please write down which numbers you see in both? So what number, when you come across, oh, I see that they both have, you're going to write it down here. Common multiples. Write that. Have you written them yet? How many do you have? All right, good. At least 3 we should have right now, right? You could have more, right? So the 3 are, go ahead. Tell me, Chloe. 6, 12, and 18. If we wanted to go another one, it would have been, what's the next number? Would have been 24, right? We would have had 22, 24, so I would have seen 24. And then it says, what is the smallest of this list? And that should be our 6. That's called our least common multiple of our numbers, okay? This is important to us, okay? Because when we are looking at our problems, today we are going to have some uglier fractions, and we want to find the least common multiple. Now, I don't always have to make a list like I did here, because if I'm looking at 2 and 3, those are special numbers, they're both prime, they have no common factors. So isn't the least common multiple actually just taking 2 times 3, and it gives me 6, okay? So when I have no common factors, right, no common factors, if I have no common factors, do 5 and 8 have anything in common? Factors of 5 are 5 and 1, it's a prime number, right? And factors of 8 are like 2 prime factors are 2 times 2 times 2. Do these have anything in common? Common factors. No, that's a multiple. 40 is a multiple, that's when you get bigger. Factors are breaking the number down. So these are the factors of 5, 5 times 1. 8 could be done as 2 times 2 times 2, and you could have a 1 in there, right? Those are the factors, okay? So do these have any common factors? Anything in common here with this one? No. Just maybe 1, but that doesn't help us. So what do we do to find the least common multiple? The least common multiple is going to be taking 5 times 8. So our least common multiple would be 40. So when you were telling me 40 for the multiple, that is a multiple, not a factor, okay? So looking at 2, 3, and 5, do they have anything in common? Yes, eventually. No factors. Factors, not multiples. Factors, Jamie. We're talking factors. 2 and 1, right? This has 3 and 1. They only have 1 in common and 5 and 1, right? They have nothing in common except 1. So how do we find the least common multiple? We are going to take the 2 times the 3 times the 5. So if these were 3 denominators in fractions, and we wanted to eliminate them, we could multiply all of our fractions by, in this case, 6 times 5 or 30, and I wouldn't have any fraction, okay? Could you use 60? Yeah, it's just that then you have to simplify later, right? So if we don't want to simplify, we use the least common multiple. All right. So this is what some of your problems will start looking like in your workbook. Top of the next page. Okay. So as we are looking at this, it says we can use the least common multiple to make equations easier to solve. So first thing we're going to look at is the least common multiple of our denominators. So we have 5, 3, and 3. My least common multiple that 5 and 3 can both go into is going to be 15. Everyone agree? 5 and 3 have nothing in common, so 5 times 3 is 15. So when we go to solve this new equation, here is how we want to write it. We're going to write our original equation. Whenever you have this x with a fraction, move that to your numerator. So we're going to think of it this way as 3x over 5. Plus, leave some space because we're going to be multiplying out in front of this. Front here, we're going to put our plus 2/3. We have that equal sign. Make sure you make your equal sign so that I can see it because it cannot disappear in the problem. And then we have 8/3, and we're going to put this parenthesis. What am I putting inside each of our parentheses is my least common multiple. And I'm going to write it as 15 over 1. And I'm going to put it as 15 over 1. And I'm multiplying every single term by that. Okay, everyone filling in their notes as we're going? Okay. So I want to start simplifying. Jamie, what do we know if we're going to simplify? 15 over 5. Because we could multiply in our calculator 15 times 3 divided by 5, but I don't want to use my calculator if I don't have to. It just takes time. So how many times can 5 go into 15? 3 times. And how about into the denominator 1? 5. How many times is 5 go into 5? I know I kind of made it like 1. Okay, Emma, how about here? It's going to be 5. 3 goes into 15 5 times. The denominator is going to be 1. And then, Andrew, if I'm looking at this next one, 3 goes into 15 5 times. And here's the most common mistake. I'll have people write down, oh, well, that's going to be 3x. What's times 3x? 3. This is 3 times this 3x, right? Plus, what's the middle term? 5 times 2 equals the last one, which is 8 times 5. Now this is going to give us a much easier equation. Brooke, what's my easy new equation? I'm going to multiply those and get what? 9x plus 10. Isn't this, for most of you, much easier to solve than if I give you this fraction? Some of you like almost lose it, like, oh my God, I can't solve this problem, right? You look at it, and you can't. You just want to make it into an easier problem. So this is our new problem. At this point, Jordan, what are you going to do? To solve. Because now we want to solve. Minus 10 both sides. Jack, once we subtract 10 on both sides, we're left with what? Yes, and some of you on the quiz yesterday, when 9 didn't go into 30 evenly, you said there's no solution. There is a number. 30 divided by 9 is that number. You could even leave it like this. I'll give you full credit. I wouldn't have in years past. I would have made you simplify, but I'd leave it. Or 3 goes into both of these, right? And I'd have 10 divided by 3. I could take that answer. I would also could change it to a mixed number. How many times does 3 go into 10? 3 and 1/3. Or I take 3.3 repeating. Now, the best answers that I would recommend in the back when you look at your answers in your checking today is either keeping it as this improper fraction, because some of you will make a mistake when you change from the improper fraction to a mixed number. Or just simply, once you get to here, this is your answer, right? Just stop at 30 divided by 9. Why go any further if you make simple mistakes with your computation? This is the correct answer. Stop. Okay? All right. So, the next two problems at the bottom of this page we're going to do. We're not going to do more fractions than this because I want to get you started on your homework. What I want you to do is to check with your shoulder partner or someone sitting by you. You can check with these guys in front of you. You want to tell me what is your least common multiple of these three denominators. And same thing here. Check, just write it down and check with your shoulder partner and make sure that they agree with what you think it is. So I want to know what's your least common multiple. 6, 10, and 30, or 6 and 9. Do it right now. Once you have both of them with the least common multiple, give me a thumbs up. One thing I might want to think of is 6 is prime factors of 2 times 3, right? 10 is 2 times 5 or 5 times 2. And 30 is 5 times 2 times 3. The least common multiple, I always want to go to the biggest number of my three fractions, the three numbers in my denominator. I have 6, 10, and 30. Can 6 go into 30? Can 10 go into 30? Yeah. That means my least common multiple is 30. Okay? You put what? 900. That's going to give us some really big numbers, and I've got to do a lot of simplifying. So, does that make sense how we want to do it? Okay? So now we're looking at that next one. We have 4, 6, and 9. The smallest it could be is 9. But can 4 or 6 divide into 9? No. So now I might want to take 9 times 4. 9 times 4 is? 9 times 4 is 36. Does 6 go into 36? Yeah. So I'm done, right? So when you look at your denominators, could you do prime factors? Yes, but then if it isn't this biggest number, like here it was the biggest one, 30, start with the biggest one and then think, oh, what if I take 9 times 4? And that one, in this case, this was our least common multiple. 4 does not divide into 18. Does it? Yeah. No. Equally. It goes into 16. Not into 18. 4, 8, 2 goes into 18. All right, so if we are showing this, what I'm going to have you write is write the original problem, but put the x's in the numerator, right? So this is going to be 1x over 6. What are we taking it times? What are we taking it times? 30 over 1. Put your plus right with me. Right with me. Your pencil is moving. There you go. Yes. We're going to have the 1/10, right? We're taking it times 30 over 1 equals 29 30ths. Jaden, are you writing? Yeah. 30 over 1, right with me. All right. So, Sam, we want to start simplifying. You ready? Yeah. Okay. 6 goes into 30 how many times? 5. 5. This is over 1. What should I write down, Sam?
5 over 1.
So 5 over 1 is just 5, right? Times x or 1x, right? So that is going to leave me with 5x, okay? Next one, Kaden. How am I simplifying? 10 and 30. What do I know? How many times? 10 goes into 30 3 times. How many times does 10 go into 10? 1. So I'm now left with 1 times 3. Now, a lot of people don't need to write the 1 times 3. They go right to this and put plus 3. I'm okay with that. Okay. Then, if we keep going, Emma, we're going to have what? So 30 over 30 is going to be the same as 1 over 1. So we're left with so we got 29. Okay. Emily, I want to get, I have this new problem. 5x plus 3 equals 29. I want to get 5x by itself, and I don't want the plus 3. What are you going to do? Subtract 3. This is a much easier problem, right, than this one up here. We subtract 3 from both sides, and Nathaniel, tell me, what are we left with? okay, 26. Like working in reverse order, I'm okay with that. Equal to the 5x. Okay, cool. What next?
I don't know.
We have 5 times x. So the inverse of multiplying by 5 is to do what?
Dividing by?
Yeah. Divide both sides by 5. And yes, as you start with fractions, you're going to get ugly fraction answers. X is equal to 26/5. Can you leave it at that? Yeah. Definitely. How many times is 5 going to 26? 5 times and 1/5. I want to write it as a decimal, then you would have 5.2, right? I don't care which of these you leave it in. To me, I'd stop at this point. You don't need to go any further. You're done, okay? All right, so Faith, you're going to tell us what to start writing for this next problem, because everyone has to do this in their homework, so they got to write it out this way. So tell me what to write.
3x over 4.
3x over 4.
Multiplied by 36 over 1.
36 over 1, okay?
Subtracted by 1/6 times 36 over 1.
Thank you. Keep going. One more.
Equals 2 over 9 multiplied by 36 over 1.
All right, Gus. You're going to help us start simplifying.
Start what? Simplify?
We're going to start simplifying. We'll start with the first one. You only have to do the first one.
Alright.
Okay. So,
What?
tell me.
Oh. Like,
So I cross those off,
Yeah.
right? Because 4 goes into 36. 4 goes into 4 how many times?
1,
One.
4, 1,
And into 36?
9.
9. Micah, go with the next one for me.
36 goes into 6 times.
Wait. You mean 6 goes into 36?
6 goes into 36.
Okay, just, because that would have been 1/6.
Yeah.
Okay, I'm good at 6, okay.
And then 1 goes into 6. Or 6
Okay.
goes into 1.
Irvin, last one.
1 goes into 36 4 times.
Okay. Chastity, tell me what I'm going to write next.
9x over 1 minus 6 over 1 equals 4 over 1. Or
6. Wait, you said 9x minus
6 over 1.
6, okay, equals,
4 times 2 or 8.
okay. So, almost right. Is it right? Okay, I agree the 4 times 2, that is going to be 8. And I agree, if we don't want to put 1 times 6, we could have just put the 6. But are we going to have 9x here? Do you see what you did? You just put the 9. So, this is, I mean, not totally fatal, but it is a mistake that students will make, and it does throw off your answers. So, it is really important that when you look at this original, that's why I would a lot of times put those numbers that are there, I'd keep them exactly the same, so that you're keeping this 3x, and then it was times just 9. And 3x times 9 is going to be 27x. And sometimes how Faith told us to write this down, she put the 3/4 x first. Notice when I did mine, I put the number in front, so that when that number's in front, I don't have 3x9, because some of you use x for multiplying, even though we kind of shouldn't anymore, but you do, and so then it almost looks like, well, so it is supposed to be 27x, and that is a mistake that people will make because they don't put this number down, okay? So showing that in your work as we do it, all right? So, Mara, you ready? Next step. Plus 6. We're adding 6 to both sides, and Aiden, once I do that, I'm left with what?
7x.
Yep. All right. Misha, what next?
We divide 27 on both sides.
Divide by 27 both sides. 27 and 14, do they have anything in common? Can we simplify? 2, 7, no. We're going to leave it. Can you change it to a decimal? If you'd like to, yes. You can stop at this point. It is 14/27. The mistake that some of you made on the quiz yesterday, You didn't do that, right? You wanted to. So, all right. We are not going to do these two problems because they're more the same, and I'd rather you get to your homework. But I do want you to write down your least common multiple for me, right below each one. So, what is the least common multiple of these three? And what is the least common multiple of these three, right? Check with your shoulder partner, tell them, and then we're going to divide into it. Do the other two numbers divide into the biggest one? 42 is the biggest. Does 7 divide into 42? Definitely. Just 14.
Yes.
My least common multiple should have been 42. We're not going to do this problem. What should the least common multiple here be?
56.
56. So start with the biggest number. Multiple means getting bigger. I just want you to put these answers down so if later you want to check or do the problems, you could. We are not going to do these two because I want to get to the decimals and I want to help you with a couple hints on homework questions. I do not want 9C. And here is the reason. So it says you can have equations with lots of decimals and you can solve them like normal. Meaning, if we wanted to solve this first problem, what would you do to solve 3.5 equals 2.45? Okay, do that, please, for me right now. Divide both sides by 3.5, or, yeah, 3.5. And tell me what you get for x.
0.7.
0.7. Okay, you could do that. It says you could solve it like normal. Or it says you can clear the decimals by multiplying powers of 10. I am going to have you, for 2 of your questions in your homework, clear the decimal. After that, I don't care if you don't clear the decimal, okay? I just want to show you how you can do this and how for some of you, it will make your life better when you don't have decimals. So, it says, what's the greatest number of decimals behind any one of these? So this one, the greatest number is 2. Do you agree? This one has 1 number behind it. This, the 4.45, has 2, okay? Here, what's the most numbers behind the decimal point? 1. I would like you right now to tell me the 2 here, write it down. What's the greatest number behind either one of these two? Write that number here, and the greatest number here. Check with your shoulder partner and just see that they have the same 2 numbers. Okay? Okay? So, the next one has 4. This one has 2. This has 3, has 1. The greatest number would be 3. Does that make sense to everyone? Okay? Multiply by what power? We're going to put 10 to the second. What is 10 to the second? 100. It is not 20. It's a 100, right? Now, it really means move the decimal, right? This really means move the decimal to the right. How many places? Whatever this power is, right? So you're going to move each one over 2 places. Please do that and write our new equation. It's going to be 350x equals 245. On your calculator. So for some of you, you like it better this way with no decimals in it. Can we divide 245 by 350?
Yeah,
Check it. Do you get the same thing as when we did it the first time with the decimals? Exactly the same answer. So does it matter? No, but I want you to make sure you know how to clear decimals. Okay? Now, here's what I don't want to see, is you taking 2.5 times 10 to the first or times 10, right? Because all this means is move your decimal over 1 place to the right. So our new equation, if we were going to write it, trailing, would be what? Or move each of these over 1 place. I'm going to have, it was 2.5. It's now going to be, move it 1 place. It'd be just 25x. So we're going to move it over 1 place and 1 place here. So 25x equals what? 24. We're not solving these, we're just writing the new equation. All right, so this one is telling us to move it 10 to the 4th. That really means move the decimal over 4 places, right? 1, 2, 3, 4. So please do that, and if it helps to actually move it, do that. No multiplying by 10,000, right? Lily, when you move it 4 places, what do we end up with? 4 x, right? Equals treasure. When I move this one over 4 places, 500. In, we're going to go 10 to the third, which means we're moving it 3 places to the right. Tell me what's the first number going to be? Yes. Equals, Jaden, what?
2x.
Yeah, that's in the last one. 2100. For some of you seeing these equations without any decimal, you just go, oh, yeah, I can do this. This is an easy problem. And you see these ones with decimals, or you see them with fractions, and you kind of like do the tent in snow. When snow falls out of tent, and you fold them. We do not want you folding. We want you standing strong, right? You guys can do this stuff. It is not hard. You have to make a decision that you can try and do this. So we are going to multiply these ones. What would you multiply, or how many places would you move this decimal? We'd multiply by 100, and you'd move it 2 to the right. Please move every one of these decimals 2 places to the right and give me the new equation. Okay? Multiply, move every one 2 places to the right, give me the new equation. What's that? Where's on your side? I'm going to take it out. And then yes, you do the same thing. What about this equation? What should we multiply by? I should multiply by 1,000. I'm going to move it 1, 2, 3 places, right? So the first one, Sam, you ready to tell me what we had?
Yeah.
Okay.
350.
Yep.
Equals 145x minus.
Yes. All right. I'm solving it. What am I doing, Sophia? Did I get it right?
No.
Yeah, I'm sorry.
You have to add 270.
Yes, add 270. So we get 620, 125x. Next step, divide by 125. Is it nice number?
Mm-hmm.
Not really. What'd you get? 4.96. 4.96. Now, you could easily check this, right? It's the same way we checked before. You put in 1.25 times 4.96. You subtract 2.7, and hopefully you got 3.5. I'm going to have the answers in the back. You can check them that way. I don't need you to physically go back and plug them in. So, new equation. Chloe, you ready to start us off?
Yeah.
Okay, go.
2,280 equals 4x plus 100.
Okay. So next step is going to be to do what, Kate?
You have to subtract 2,100 from each side.
Yes. So when we do that, we're left with 180 equals 4x. And this one actually comes out nice, not even a decimal, right? X equals 45. Okay. I had someone say, Mrs. Thompson, if I was going to solve this, could I have just done, here's the original problem, right? 2.28, 0.004x plus 2.1. If I was solving this and I didn't want to multiply, I could subtract 2.1 from both sides, right? I would have had 0.18 equals 0.004x. On your calculator, would you please take 0.18 divided by 0.004? 0.18 divided by 0.004. Same. So does it matter if you get rid of those? No. I just want you definitely in tonight's homework want to clear all the fraction ones, right? So I definitely want to get rid of 5, 6, 7, 8, 9. I want to clear the fractions. I want you to use the multiplying for sure in 1 and 3. So, because 3, I have people make this fatal error in their homework. So, number 1, I just want you to put right behind it, what would you multiply by? 10, 100, or 1,000? In number 2, I want you to do the same thing. What would you multiply by? Or number 3, 10, 100, or 1,000? Yeah. So just, I want you to do this as we're doing it. So for 1 and 3, I want you to do them this way. Thus, working ahead, you might have to redo it now.
I have to redo it.
Yeah. Because the fraction ones, we don't want, we're going to clear those fractions. Thus, maybe waiting so you don't do double work. But what do we get for number 1? 100. How about number 3? 100. Write the new one for number 1. And right now, let's write together the new one for number 3. Because this is where people make a really bad mistake. So if I am multiplying this by 100, 100 times 6.02 is going to move it over 2 places. That gives me 602. Plus u. What happens when I take u times 100? It's 100. I'll have many people just leave this like this. They'll just leave the u. Because they're like, well, there's no decimal in it. Remember, that is a 1 in front, and 1 times 100 is going to be 100u. Keep your equal sign. Then we're going to have what for the next one? 200. Minus 150. Is that making sense? Okay. Let's do 5. What is our least common multiple in 5 that you're going to multiply? Now I'm going to let you work. 5. What do I want to multiply? Everything in 5. I go to my biggest number of 5, 10, and 5 is 10. Is that my least common multiple? Does 5 go into 10? So that's what I want to use to multiply. When I start the problem, this is going to be my 10 over 1. I'm going to start with that. Write this down. You're not writing. Right below number 5. And those of you that write massively, and you know who you are, like between 5 and 6, you made this your whole. Get a sheet of notebook paper in the back and make sure that you know, if you use half a page for a problem, I'm okay with that. But you know, you people that are my large number writers, spread it out. Do it on notebook paper because this isn't enough room for you, right? We're going to have 4m over 5, right? Minus, I'm going to keep putting that 10 over 1. And then I'm putting, in this case, it was 3/10 equals. I'm going to put 10 over 1 times 3/5. So that when I look back at the problem, I should see, oh, this original problem, all of that is here. And what is different is that I now have my least common multiple times each one, right? That's the work I need to see when you're doing this. Now, after you've done this a while, and like Monday's homework and next week, and you start to not have to show what you got when you multiply, if you're good at your math, and you're going, oh yeah, this is 1 and 2. Right now, I want you to put 2 times 4m, so there you're showing me 8m. Right? Because some of you are making some easy mistakes that you shouldn't make, but this might help you out just a little, okay? All right, so the remainder of class is yours to go to work on this. And I am going to try and, if you have questions, maybe answer them. And I'm going to be trying to correct your quizzes up here. But if you have definite questions, check with me.